My name is Eric Schuettpelz. I'm a relatively new addition to the botany department here at the Smithsonian. As you've certainly guessed by now, I work on ferns. I'm a systematist interested primarily in the taxonomy and phylogeny of this group, but I'm also really interested in the diversification of ferns, and I'm going to tell you a little bit about some of that work today. Now, on face value, the whole idea of fern diversification and studying it may seem a little bit odd because ferns, of course, are pteridophytes. They're plants that are vascular plants, but that disperse through spores. And you may know the fate of pteridophytes broadly in the fossil record. As seed plants, gymnosperms and angiosperms in this graph, came on the scene and began to diversify, pteridophytes were largely pushed to the sidelines. And if you look at the living diversity of seed plants and pteridophytes, you can see that this is quite obviously manifested today. Seed plants account for well over 95% of the world's living vascular species. But as it turns out, this is a little bit of an oversimplification. There are actually many lineages of both pteridophytes as well as seed plants. And these are lineages that have been around for a long time, hundreds of millions of years separated from one another. And you can see that the vast majority of these lineages contain just a handful to a few hundred species. There are two groups of vascular plants that I would consider rather exceptional in terms of their diversity. One of these, of course, are the angiosperms, the flowering plants, which are obviously dominant on our planet, both in terms of their abundance and their diversity. But I would also consider the leptosporangiate ferns to be an exception to this rule of a very small species number. Now, based purely on those numbers, right, anything that you would probably think of as a fern is indeed a leptosporangiate fern. These things do also have some morphological synapomorphies, specifically the presence of a leptosporangium. This is the case in which the spores are produced in leptosporangiate ferns. We know from the fossil record that leptosporangiate ferns have been around for a really long time, probably over 300 million years. There's also some evidence in the fossil record that leptosporangiate ferns may have begun to diversify much more recently than that time. So my colleagues and I examined this several years ago, bringing together some information from the fossil record along with some molecular phylogenetic data to look at the diversification of leptosporangiates through time. This phylogeny, or tree of leptosporangiate fern diversity, is calibrated to time. So if you start on the far left, you're deep in time, moving toward the present. And I want you to pay attention not only to where the branching events in this tree happen, but where the diversity lies in this tree. You'll see those bottom three groups, the pterodoids, Eupolypods 1 and Eupolypods 2, collectively contain about 80% of leptosporangiate diversity. And those groups did not begin to diversify until in the Cretaceous and Tertiary, when flowering plants were already on the scene. And it was for that reason that we suggested that not only did these things diversify following the diversification of flowering plants, but that flowering plants may have been somehow involved in their diversification. Now, of course, at the time, that evidence was rather circumstantial, right? You're seeing two groups diversifying in correlation with one another. But it was an interesting hypothesis that I wanted to follow up on. So more recently, I expanded that sample by about an order of magnitude, increasing the species level sampling in the analysis to about 400 leptosporangiate fern species. And this is another time tree, right, starting in the deep past, moving to the present at the top. You can see that the pattern is largely consistent. Most of the divergences happened after or into the Cretaceous and the Cenozoic. So they're relatively recent diversification. And in this study, I was focused specifically on a type of fern, which we refer to as being epiphytic. An epiphyte, whether it's a fern or another organism, an epiphyte is an organism that lives on another organism. Or I'm sorry, another plant. In the case of ferns, these are ferns. About 30% of fern species are epiphytes that are growing on tropical rainforest trees. And in this study, we were able to demonstrate that the bulk of epiphytic fern diversification actually happened after the KT boundary, at which time we think that modern tropical rainforests dominated by flowering plants were established. So again, the evidence is a little circumstantial, but we're getting closer. We're getting closer to sort of providing some evidence that flowering plants may have actually been involved. Of course, if flowering plants were involved, we would expect there to be an increase in diversification rate in leptosporangiate ferns about the time that flowering plants came on the scene. From that data set, we see a relatively constant rate of diversification, as shown in this straight line. So yet again, I increased the sampling, this time by another order of magnitude, now including about a fourth of all fern species. And you can see something interesting emerges from this study. We begin to see a relatively constant rate of diversification, but around the time that angiosperms come on the scene, about 100 or so million years ago, we see an uptick. We see an increase in the diversification rate of leptosporangiate ferns, suggesting that flowering plants may well have increased the diversification rate of these plants. Obviously, the evidence is still a bit correlative rather than causative. A lot of work still needs to be done. But I think one thing at least is certain, and that's that the bulk of leptosporangiate fern diversity emerged following the rise of flowering plants. Thanks for your time.